So this is part 2 of section 2.3, more using the chain rule. The big difference in part 2 is that we're going to have to start combining rules. If I look at problem 34, I have y equals to 5x squared. There isn't a times sign, but I'm going to emphasize times 7x plus 1 quantity cubed. This is a multiplication problem. Both factors have an x. And when you have multiplication where both factors have an x, you have to use the product rule. If that 5 was alone and didn't have the x squared, then it would be just like the first half of the video. But now it's ugly. So I have to remember the product rule. It's used when there's multiplication and both factors have an x. And remember the rule is the derivative is the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So in order to do the derivative of either 33 or 34, I'm stuck using the product rule. So because there's multiplication and both factors have an x. So let me write down the factors here. I have this slick new pen that I want to use, but I don't think it works so well. It's maybe too small. So the first factor is 5x squared. The second factor is 7x plus 1 quantity cubed. Those are the two factors that are being multiplied. They both have an x. The derivative of the first factor, I just bring the 2 out front, multiply it by the 5, lower the exponent by 1, and get a 10x. And the derivative of the second, because it's a parentheses with an exponent, I need to use the chain rule. So the derivative of 7x plus 1 cubed, I bring the 3 out front, I lower the exponent by 1, and then where I have that room, I multiply by the derivative of what's inside the parentheses. The derivative of 7x is just 7. The derivative of 1 is 0. So the derivative of the second, I'm going to say it's 21 times 7x plus 1 squared. So now I'm set up to do the product rule. I'm finding a derivative. There's a multiplication and both factors have an x. In the last part of the video, if there was multiplication and both factors didn't have an x, I don't need to use the product rule. So when I did problem 31 for you, the 4 that was in front of the fraction parentheses with the fraction exponent didn't have an x, so I didn't need to use the product rule there. Turned out I could have used the product rule, but the first factor would have been a 4 and its derivative would have been a 0, so that piece that had one of the pieces would go away. So let me try to write the derivative down now. So I'm going to write y prime equals first factor is 5x squared times the derivative of the second factor, so times 21 times 7x plus 1 squared, plus second factor, which is 7x plus 1 cubed, times derivative of the first factor, which is 10x. This is a correct derivative. This definitely requires some simplifying, and usually when you're doing the chain rule along with the product rule, the simplifying is common factor factoring. Let me try to show you the common factors one at a time. Between this 5 and this 10, I'm going to factor out a 2, because I'm going to factor out a 5. Duh. Between this x squared and this x, there's 2 x's and 1 x. There's single x's without any adding or subtracting. I'll factor out the smaller of the exponents. I'm going to factor out an x. And between the 7x plus 1 squared and the 7x plus 1 cubed, there's a common factor of 7x plus 1. You'll take the smaller of the exponents. So there's 3 pieces to the common factor. I look at single numbers, the 5, the 21, and the 10. I could have multiplied the 5 and the 21 and made it into 110, but I didn't have to. So I looked single numbers, x's without parentheses, common parentheses, pulled out the common factors. So from the first piece, I factored out the 5, so that 5 is going to be gone. There were 2 x's. I factored out 1x, so I'm going to be left with 1x. I didn't deal with the 21, so the 21 is going to be there. So if 5 is gone, it's factored out. One of the 2 x's is factored out. One of the x's is left. The 21 is still there. I factored out the entire 7x plus 1 squared, so it's gone. So from the first piece, what's gone is the 7x plus 1 squared, the 5, and 1 of the 2 x's. After the plus sign, I factored out 2 of the 7x plus 1's. I'm still left with 1 of them. So technically, I'm left with 7x plus 1 to the first power. This 10, when I factored out a 5 to figure out what's left, I have to take that 10 and divide it by 5. That's going to leave me with a 2. Instead of writing it after the parentheses, I'm going to write it before the parentheses. And this x I factored out completely because I factored out an x and there was an x. So real quickly here, there were 3 7x plus 1's. I factored out 2 of them. I'm left with 1 of them. There was a 10. I factored out a 5, and 10 divided by 5 is 2, so I'm left with a 2. I factored out an x, and I only had an x, so there's no x left. So inside this second parentheses, I don't know why I'm changing colors here, I'd probably clean that second parentheses up to get the best possible answer for this. And inside that second parentheses, I have 21x to the left of the plus sign, and then after the plus sign I have a parentheses with a number in front of it. I'm going to clear that parentheses by multiplying 2 times 7x and getting 14x, and 2 times 1 and getting 2. And so probably for a best answer for problem 34, I'd say the derivative is 5x times 7x plus 1 squared, and then 21 and 14 is 35. Leave the x, and then keep the 2 at the end. I wouldn't go any further. I suppose you could multiply things down a bit more, but I probably wouldn't go more than that. So your problem 33 is going to be equally as ugly. And we'll move on to the next page, and I'll do 35 with you. So if you want to pause the video and give 35 a shot. 35 has multiplication. Both factors have a letter, not necessarily an x. So I have to use the product rule. So in order to do problem 35, I look at this. There's multiplication. There's the 2 parentheses touching each other implies multiplication. And when you have multiplication and when each of the factors has a letter, it doesn't have to be an x, you need to use the product rule. So the first factor is just the first parentheses. I don't really need to write the parentheses when I call it the first factor because it doesn't have an exponent. The second factor, I need to bring the exponent because it has a parentheses. So I'm using the product rule. There's multiplication. Both factors have a letter. And in order to use the product rule, I need to identify the factors and find their derivatives. So I wrote down the first factor. Now I'm going to find the derivative of it. For the first term, t squared has a derivative of 2t. Positive 6t has a derivative of positive 6. Minus 1 has a derivative of 0. I don't know if I should factor out a 2 there. I'm almost thinking that it would make sense to factor out a 2, but I'm not going to right yet. At some point I might pull out that common factor. I'm not sure if it's going to make the math easier by pulling out a common factor of 2 or harder. I can't see in my head what's going to happen, so I'm going to leave it like that. So first factor, its derivative. Second factor, its derivative. To do the derivative of the second, I bring the exponent out front, leave some room, using the chain rule, lower the exponent by 1. So I'm just using the chain rule, exponent out front, leave the contents of the parentheses, lower the exponent by 1, leave yourself some room, and where you leave that room, write the derivative of each term inside the parentheses. The derivative of 2t is 2, the derivative of 5 is 0. So for the derivative of the second, I'm going to say it's that. So now I'm going to write my derivative for problem 35. So I'm going to say the derivative equals 2. What is it? It's first factor. I'm going to put it back in a parenthesis, so t squared plus 6t minus 1 times the derivative of the second. I'm going to write that to the left of it. Just I want the number first. Rather than you can flip-flop these, and this feels like a time having that written second was going to make it harder to see the common factoring, I thought. So there's the first factor times the derivative of the second, and then plus sign. And I wrote it backwards just because I just felt like it felt good. And then second factor times the derivative of the first. I should have factored out that 2. Just because it's going to make it easier, I'm going to pull out a common factor of 2 from this first derivative of the first. And instead of writing 2t plus 6 here, I'm going to write 2 times t plus 3. Same deal. I like the number to be written first. Sorry, as I crud this up. I'm going to write, instead of writing it that second, I'm going to write it first. And I'm going to write this whole thing over just so you could see it. So I should have written here. So for the first factor times the derivative of the second, I wrote them backwards. I did this derivative of the second times the first factor. And then for the second factor times the derivative of the first, I also wrote them backwards. So that's the derivative. Now I start looking for common factors, and between this 4 and that 2, I can factor out a 2. Between this 2t plus 5 and that 2t plus 5 squared, I can factor out the smaller of the powers. The smaller of the powers is the first power. So I've dealt with the 4, I've dealt with the parentheses 2t plus 5. This t squared plus 6t minus 1, I could only factor out if there was a parentheses that was identical to it on this side, which there isn't. So that's all the common factors I can get out of this. I don't know why I'm randomly changing colors, but I'm dealing with it. So now, to the left of the plus sign, this 4, when I factor out a 2, I'm going to divide it by 2, and it's going to turn into a 2. I factored out this 2t plus 5 completely. I haven't done anything with the t squared plus 6t minus 1. To the right of the plus sign, I factored out that 2 completely. I haven't done anything with that t plus 3. And I factored out 1 of the 2t plus 5, so I'm left with 1 2t plus 5. Usually, this big parentheses is where I start to simplify, and I'm going to simplify the inside of that parentheses and combine like terms. So when I start to write an answer for problem 35, the common factor is not going to change. This 2 times 2t plus 5 is going to be part of my answer. But I'm probably going to get a longish parentheses next to it. Well, maybe not so long. And that's going to be the simplification of this mess. So I'm going to simplify this mess. I'm going to multiply the 2 by the 3 terms inside the parentheses that it's next to, and get a 2t squared plus 12t minus 2. And this piece I'm going to FOIL. I'm going to go t times 2t is plus 2t squared. T times 5 is plus 5t. 3 times 2t is plus 6t. And 3 times 5 is plus 15. Now I'm going to combine like terms. First like terms are going to be 2t squared plus 2t squared. And when you're adding, just the coefficients change, the exponents don't. So the 2t squared plus 2t squared is going to be 4t squared. And then I'm going to do this 12t, that 5t, and that 6t. 12 plus 5 is 17 plus 6 is 23. So I'm doing 12 plus 5 plus 6. I'm going to get a 23t by those 3 items that I underlined. And then lastly, the minus 2 and the plus 15 come out to a plus 13. I think that's the best answer. There's a parentheses with a square. I might as well see if it factors. Super easy to do. So just program quad a equals to 4, B equals to 23, C equals to 13, decimal, so it's prime. So this would be the best answer for problem 35. And usually when you're using the chain rule in combination with the product rule, we absolutely start pulling out common factors. So same deal. If you get the derivative kind of this far, that's most of the credit. Since the simplifying is more complicated here than the beginning problem simplifying, it might be like a -2 if you don't simplify it as nicely as I did. All right. Wow, 15 minutes, I think 2 problems. So you might be able to do 37 without me. I'm going to do 38. So for 38, there's multiplication. Both factors have a letter, so it's a product rule. So in problem 38, my first factor doesn't have an exponent, so I don't need to write it in a parentheses. It's 2y minus 3. The second factor, because it has a parentheses with an exponent, I need to keep that parentheses. Do the derivative of each. The derivative of the first, since it's just a first easy polynomial, the first piece has a derivative of 2, the second piece has a derivative of 0. The derivative of the second, I need to use the chain rule. Bring the exponent out front, lower the exponent by 1, leave the contents of the parentheses the same, and then leave yourself some space. Multiply by the derivative of what's inside the parentheses. The derivative of 4y is 4. The derivative of 1 is 0. So I'm going to say this is 8 times 4y plus 1. So now I need to do first times derivative of the second plus second times derivative of the first. Product rule because it's multiplication. Both pieces have the letter. So I'm going to write f prime of y equals first factor. I'm going to sneak it back into a parentheses. First factor is 2y minus 3. Derivative of the second. I guess I want that written first. I like the number written first. So instead of writing this like this, which is fine, instead of writing it that way, I'm going to write it backwards. I'm probably going to consistently do that. And you're allowed to do that. Multiplication's commutative. You can flip-flop the order, and it's not going to make the result wrong. So this is the first factor times the derivative of the second, just written with the derivative of the second times the first. Now I'm going to bring down my plus sign, and then the second factor is 4y plus 1 squared, and then the derivative of the first. So second factor is 4y plus 1 squared, and then times the derivative of the first. Instead of writing it after the parentheses, I'm going to write it before the parentheses. So I wrote both of these backwards, but all I'm doing is multiplying these and multiplying these, putting them on opposite sides of a plus sign, and you can write them whichever one first that you want. Now common factor. Between this 8 and this 2, there's a common factor of a 2. Between this 4y plus 1 and that 4y plus 1 squared, there's a common factor of 4y plus 1. It's the smaller of the exponents. Now I'm going to figure out what's left. From this 8, when I factor out a 2, I'll divide the 8 by 2 and get a 4. I'll be left with a 4. This 4y plus 1 I factored out completely. And that 2y minus 3 I haven't dealt with. I'm going to leave it in a parentheses. So to the left of this plus sign, I'm left with a 4 from that 8. That's gone. I'm left with that 2y minus 3. After the plus sign, I factored out that 2, so it's gone. I had 2 4y plus 1s. I factored out one of them, so I'm just left with 1 4y plus 1. Didn't really even need the parentheses anymore. So now I'm going to simplify this right parentheses. I'm going to go 4 times 2y is 8y. 4 times minus 3 is minus 12. I'm going to drop that parentheses because I don't really need that parentheses because it just has an exponent of 1 and there's no negative or multiplication associated with that parentheses. And get ready to write my answer. The common factor is just going to hang out front. And what's left after I simplify what's left, 8y plus 4y is 12y. And minus 12 plus 1 is minus 12, plus 1 is minus 11. So that would call that a best answer for 38. It's already 20 minutes, and I'm going to start making some calls here. It's very specifically, my first call is going to be to skip 39 and 40. We skipped a few problems in the section of the product and the quotient rule. And these aren't going to come up again in our class. They don't come up in Math 218, and they're more complicated. Maybe they're more for Math 220 for those people that are going on to like Engineering Calc 2 and Engineering Calc 3. The math that's buried in these problems is maybe more important to them. It's not very important to us. So, more grunge though. So, 41 and 42, it's division. When we have a division, we certainly can use the quotient rule. So what's the quotient rule? Quotient rule is says if you have a fraction, the derivative of it, you take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Well, I'll do 41 with you. If you want to make a shot at 41 because you're feeling bold, go ahead and give it a try. If not, I'll show you how to do it. So for 41, it's division, so I'm going to use the quotient rule. The numerator is 2. The denominator is 3x minus 4 to the 4th. Now I need to do the derivative of each. The derivative of the numerator, it doesn't have an x, it has a derivative of 0. For the derivative of the denom, because it's parentheses with an exponent, I need to use the chain rule. I'm going to bring the 4 out front. I'm going to leave the parentheses unchanged, lower the exponent by 1, and then where I have that room, I multiply by the derivative of each term inside the parentheses. The derivative of 3x is just 3. The derivative of minus 4 is 0. I'm going to multiply that 4 and 3. So those are the pieces that I'm going to need for the derivative. So I have exactly everything I need. So I'm going to go for problem 41, y prime equals, form a fraction. First piece is the denominator. The denominator is 3x minus 4 to the 4th times the derivative of the numerator, which is 0. This piece is going to turn into 0 because anything times 0 is 0. And then minus the numerator, which is 2, times the derivative of the denominator, which is 12 times 3x minus 4 cubed, all over the denominator squared. All over 3x minus 4 to the 4th squared. So, have the derivative. Now I'm just going to simplify it. This piece comes out to be 0 because anything times 0 is 0. For the piece after the minus sign, I'm just going to multiply the 2 and the 12, or the minus 2 and 12, and get a minus 24. So it's going to give me minus 24 times 3x minus 4 cubed. And in the denominator, if something has an exponent and you're squaring it, you need to multiply the exponents to do the squaring. So the denominator is going to be 3x minus 4 to the 8th. And there's not really common factor simplifying per se, but there's canceling. So the common 3x minus 4 to the 3x minus 4, you can cancel. And when I cancel, this is a Math 120 trick that you might not remember, but it's not a hard trick to pull back. If you're simplifying and you have common factors, you subtract the exponents and leave the factor where the bigger exponent is. The bigger exponent is 8. 8 minus 3 is 5. I subtract the exponents, simplify it to leave the exponent where the larger exponent started. So that's probably a best answer for problem 41. Problems that get progressively grungier. Let's look at 43 and 44. Same deal. Let me do 43 with you. You can pause the video if you want to give it a try. I think this one's going to be kind of nasty. So, it's division, so I need the quotient rule. The numerator is 3x minus 1 quantity squared. The denominator is 2x minus 5. The derivative of the numerator, I need the chain rule. Multiply the exponent out in front of the parentheses, lower the exponent by 1, then multiply by the derivative of the inside of the parentheses. The derivative of 3x is 3, the derivative of minus 1 is 0. So the derivative of the numerator is just going to be 6 times 3x minus 1. The derivative of the denominator is just going to be 2. That's everything I need. So, oh, look at this. I have t's and x's. I either need to have both x's or both t's. Let me change that to f prime of f of x as opposed to f of t. It doesn't make sense to have the letters conflicting. So when I go to write the answer, I'm going to say the derivative is big fraction. First, the denominator. I'm going to put it in a parentheses. Denominator times the derivative of the numerator. So after the 2x minus 5, I'm supposed to write this there. I'm going to write it first again just because I like to have the single number first. So that's right here. This is the part that's the denominator times the derivative of the numerator, and then minus the numerator times the derivative of the denominator. Again, I'm going to write it here. All over the denominator squared, and I just throw a parentheses and square it. Illegal to cancel those. Now I look for common factors to simplify this. Between this 6 and this 2, there's a common factor of a 2. Between this 3x minus 1 and that 3x minus 1 squared, there's a common factor of 3x minus 1. So when I go to simplify the numerator, I never FOIL out the denominators in these problems. When I go to simplify the numerator, I pull out my common factor, leave myself a parentheses. This 6, when I factor out a 2, I'll divide the 6 by 2. It'll turn into a 3. This 3x minus 1, I factored it out, so it won't stay there. The 2x minus 5 is going to stay because I haven't factored it out. Bring down the minus sign. After the minus sign, the 2 I factored out, so it's gone. The 3x minus 1 squared, I factored out one of them, so I'm still left with 3x minus 1 to the first power. Needs to stay in a parentheses so that when I simplify, I don't mess up with the negative sign. So almost done. All I need to do now is clean up the inside of that parentheses that's left after the common factor. Turn it into something nice. Let me try to do that right kind of in line so I'm not running out of room. Inside of this parentheses right here, I need to simplify up by going 3 times 2x, 3 times minus 5, and then the minus in front of the parentheses is going to change both the 3x sign and the minus 1 sign. So this is going to turn into minus 3x and plus 1. So inside that parentheses, 6x minus 3x is 3x, minus 15 plus 1 is minus 14. This is the best answer. Never would put something like this on a practice test or a test, but maybe it's kind of fun to do if these are starting to be fun-ish. All right. It was disgusting. Making the same vote to skip 45 and 46. We don't need to use radical problems in this area. It's just more complicated. I hate to throw 47 through 52 into their own video because 47 through 52 don't take that long, but burying 47 through 52 at the end of a section is also a bad idea. I'm torn, but I'm just going to throw it at the end here. These are on the test actually, so they're kind of important. So we'll do 47, 48, 49, 50, 51, 52, all of them. And they all have a part A and a part B. Part A says find all values of x where the tangent line is horizontal. Horizontal lines have a slope of 0. And this instruction, I mean, for most students would mean absolutely nothing. What would have been nice to write is what you're going to wind up doing. So for part A, we're going to find the derivative then set derivative equal to 0. And solve for x. Simple enough to do, so let me do 48a. So for 48 part A, I'm going to find the derivative of this simple parentheses with an exponent. So I'm going to use the chain rule. I'm going to say the derivative is, I'm going to bring the exponent out front. I'm going to lower the exponent by 1, and I'm going to take the derivative of each term inside the parentheses and multiply that by the 2. The derivative of 3x is 3. The derivative of minus 4 is 0. So the derivative of this is going to be 6 times 3x minus 4. If I want to, I could clear the parentheses. It might actually make it easier. So let me clear the parentheses. In general, I wouldn't. But it's probably going to make the math more followable for you if I do that. I don't have to do that. I can get the answer to part A leaving it factored, but I think it might make a mistake if you don't unfactor it. So I found the derivative, which is f prime of x equals either the factored or unfactored form. Now I'm going to set the derivative equal to 0 and solve for x. There's not a square, so I don't need to factor. I add 24 and divide by 18. And I get x equals to, this divides by 6, I think. I think it's 4/3. Let me do on my calculator. 24 divided by 18, math, and enter twice. What I could have done, I could have left it unfactored and just set the unfactored version equal to 0. Then I would have done 6 equal to 0 and 3x minus 4 equal to 0. So had I left it factored, I would probably split the factors and set them equal to 0. The first factor doesn't have a letter. It doesn't give a solution. The second factor of 3x minus 4, I would add 4 to both sides and then divide by 3. So whether I did or didn't take the time to multiply out the parentheses, after you find the derivative, you set the derivative equal to 0. Whether you leave it with the parentheses or clear the parentheses, you still get the same answer. So the answer to 48a is x equals to 4/3. Done with part A. I'm going to need a whole sheet of paper to do part B. So part B wants me to find the equation of a tangent line, and in order to find an equation for a line, you need two things. You need a slope and a point. So for 48b, to find the equation of the tangent line, I need two things. I need a slope and a point. And the point is going to have an x-coordinate of 4/3 because that's what my algebra gave me when I did 48a. That's the value of x that the tangent line is horizontal. It doesn't specifically give me the slope, but it implies the slope because it's asking me to find an equation of a horizontal line, and horizontal lines have slopes of 0. So the word horizontal in part A implies the slope is 0. So when I go to find an equation of a line, I need a point and a slope, and just like I think in section 2.2, it might have been section 2.1, but just recently we found equations of tangent lines. I need a point and a slope. The slope, usually get the slope by plugging the value of x into the derivative, but I don't need to do that here because horizontal lines have slopes of 0, so I could skip that step and be clever. The algebra gives me the x coordinate of the point. Algebraically, to finish this up, I need the y coordinate of the point. So to finish this up, I need to find the y coordinate by using not the derivative, but using the original function. So I'm going to use the original function, and I'm going to plug 4/3 in for x. So I'm going to go f of x equals 3 times 4/3 minus 4 squared. That's all I'm doing is plugging that in. I think that comes out to... It comes out to 0. Let me try that. So do this. Parentheses, 3 times 4 divided by 3 minus 4 parentheses squared, which is 0. So this is going to be the y coordinate of the point. I don't think it's always going to be 0, but in this case it's 0. And I'm off the screen here. So the y coordinate of the point is 0. Now I have a point and a slope. Slope is 0 because it's a horizontal line. I could have gotten the slope by taking 4/3 and plugging it in for x into the derivative. It still would give me the same 0. The algebra for part A gave me the x coordinate. Taking the x coordinate, plugging it into the original function gives me the y coordinate. Now to find an equation of a line, I'm going to use the y minus y1 equals m times x minus x1 formula. So I'm going to go y minus the y coordinate, which is 0, equals m, which is 4/3, times x minus the x coordinate, which is m. I'm going to go m equals to 0 times x minus 4/3. Mess that up. So y minus the y coordinate equals m of 0 times x minus the x coordinate. The nice thing about this is the left-hand side simplifies just to be y, and 0 times anything is 0. So the answer to part B is just y equal to 0. Let me walk through 49 with you. It's a little bit harder, and hopefully you can give 47 a go and see what you can do with it. I'll walk through 49 with you and see what we can do. And maybe we'll just do, well, there's one more problem after this. Let's just do 49 and see how I'm feeling after this. So 49A, find the values of x where the tangent line is horizontal. And that tells me to find the derivative set the derivative equal to 0 and solve for x. So that's going to be part A for this. So derivative, it's a product because there's multiplication and both factors have an x. I need the product rule. So to do the derivative, I need the first factor. The first factor is 4x. The second factor is x minus 1 squared. I need the derivative of the first, the derivative of 4x, since the first power term is just the 4, and the derivative of the second, where I bring the 2 out in front of the parentheses, lower the exponent by 1, using the chain rule, and then multiply by the derivative of the contents of the parentheses. The derivative of x is just the number in front of the x, which is an implied 1. The derivative of 1 is 0. So the derivative of the second is just 2 times x minus 1. So that's everything I need for the derivative for part A. So the derivative using the product rule, first factor times the derivative of the second factor, so 4x times 2 times x minus 1. So that's first times derivative of the second. And then second times derivative of the first, that's x minus 1 squared times 4. I'm going to write this product with the 4 first. So 4 times x minus 1 squared. And now I could common factor, or I could multiply out. It's probably better to common factor. I'm going to factor out a 4 and an x minus 1. I'm going to leave this x and this 2 alone. So simplifying this, first piece I factor out a 4 and that x minus 1. When I factor it out, I took both the 4 and the x minus 1 out. I'm left with the 2x. After the plus sign, I factored out the 4, but only one of the x minus 1 squared. So I'm still left with 1x minus 1. Doesn't really need to be in a parentheses anymore because that's a plus sign. Inside the parentheses, I'm really left with 2x plus x minus 1. I could just drop that parentheses, and that x is really a 1x. So I'm left with 2x plus 1x minus 1, which is 3x minus 1. So I found the derivative. Now I'm going to set the derivative equal to 0. I'm going to go 4 times x minus 1 times 3x minus 1 equals to 0. It's factored, so I should set each of the factors equal to 0. I'm going to go 4 equal to 0, x minus 1 equal to 0, and 3x minus 1 equal to 0. The 4 equal to 0 doesn't give a solution because I don't have an x. The x minus 1, I add 1 to both sides and get x equal to 1. The 3x minus 1, I'm going to plus 1 to both sides and get 3x equals to 1. And then divide both sides by 3 and get x equal to 1/3. I think I'm going kind of fast, but I know this complexity doesn't come on the test. So the answer to 49a, the values of x where the tangent line is horizontal is x equal to 1 and x equal to 1/3. Because there's two answers to part A, there needs to be two lines that I need to find in part B. So done with part A, moving on to part B. So the original function is y equals to 4x, y equals to 4x times x minus 1 squared. I'm going to find an equation of two tangent lines. One where the x coordinate of the point is 0. Wow. I'm fading on you, I'm sorry. One where the x coordinate is 1, and another one where the x coordinate is 1/3, using the two answers that I got from part A. Those are the two values of x where the tangent line is horizontal. I'm going to get two different answers. The slope, because I'm doing horizontal lines, for each of these is going to be 0. To finish up, I need to get the y-coordinate of each point, and I get the y-coordinate by just taking the value of x that I have written down and plugging it into the original function. So every time I'm going to find an equation for a line, I need a slope and a point. The algebra for part A gives me the x coordinates of the points. The fact that part A said we're finding horizontal lines and horizontal lines have a slope of 0 sneakily give me the slope. And then to finish up the points, I need to get the y coordinates, and I'm ready to use my calculator for those. So 4 times 1 times 1 minus 1 squared. This y coordinate is 0. And then 4 times 1/3 times 1/3 minus 1 squared math, enter, enter. This y coordinate is 16 over 27. So no need to do the fraction work by hand unless you just enjoy doing it by hand. So now I have, for two different lines, a slope and a point. Now for each, I'm going to find the equation using the y minus y1 equals m times x minus x1 formula. So for this one, I'm going to go y minus the y coordinate, which is 0, equals m, which is 0, times x minus the x coordinate, which is x minus 1. And on this side, I'm going to go y minus the y coordinate, 16 over 27, equals m, which is 0, times x minus the x coordinate, x minus 1/3. Now I'm going to simplify. They simplify so easily. This one, the left side simplifies to be y. 0 times anything on the right side is 0. This side, the left side, doesn't reduce, but the right side comes out to be 0. And then I'm going to add 16 over 27 to both sides and get y equals to 16 over 27. That's going to be the equation of my line. This is a good thing because horizontal lines, their equations don't have x's, they only have y's. So for 49b, the answer I'm going to write down is y equal to 0 and y equal to 16 over 27. I could probably show you something slick on the calculator that kind of explains what this means, but we're so deep into this video, I don't think I want to go further. And I'm making another executive decision. If you want to try 51, give it a try. If not, you can skip 51. This section's getting a little bit long, so feel free to skip 51 and 52. I'm completely content with the amount of work that we've done in this section. But if you want to do any of the problems that I told you to skip, feel free to try them. Those first 20 problems, if you want to come to my office, I could explain to you the theory that's kind of behind the chain rule that I completely ignored. All right, that's got to be a good stopping point.